Hello guys, have you ever tried to make an ocean simulation? Then you came to the right place. And if you want to learn really fast, you can join into my Discord channel. Okay, so to start with, we're going to load the boat in the description. In this case, I saved it to the HIP file. So let's bring it down to real scale. In this case, it's going to be around 100 meters long. Remember guys, if you want to make the simulation smaller, because you need some power on your PC, do so. You shouldn't follow everything as exactly in my tutorial. So we have this error in the viewports, and we're going to fix it by by deleting the attribute delete, and we will use this symbol on each one of the spaces here. So let's use a point normal, like so, and now we have our ship. So I know I want to place this boat like so. I just grab the null and start moving the boat around, and this is okay, this is fine for me. So let's create a BDB out of it, but before let's create a null. This is going to be the out ship. There we go. So the out ship will be turned into BDB. So BDB from polygons. Let's set .4 for the scale, and then we have a really nice BDB. It's actually not that heavy, only 3 million voxels. So let's do an out ship SDF, out ship pol SDF. Let's convert this back into a polygon mesh with this feature polygon. Let's watch the mesh. So this is really high density, and we could make maybe an activity to 0.05 to keep the detail but also lower the mesh resolution. So we went from this amount, which is 800,000 to barely 0.05, but we can also poly reduce this even further to, let's say, 10%, and let's see how it looks. Okay, so this is really rough, but I think it's going to work. Maybe 10% will be a little bit better. So this is going to be the out call poly. Now we got ourselves the shape collision of the ship. Now let's visualize this and let's create a couple of rocks. For example, let's make a box, and let's move this box around here, and let's make it, I know, way bigger, and with the letter S. While watching this, let's select this one and press edit. Now we can make this edition way smaller, and move this around like so. So let's play along with this. This should be fine. This should also be fine. And let's move it as we please. For example, somewhere around here, like the ship collided with a rock. But we are not done. I mean, this is only a couple of polygons. We should have this as a rock. So let's add a merge here. You can add as much, or as you can add as many rocks as you please here, like so. And let's create a BDB from polygons, and let's use 2, for example, and 30 and 30. We need this space so we can displace the mesh with the volume buffer. Remember, we know that the surface is named, remember, we know that the distance is named after surface. So let's hop in, let's sample, let's volume sample, let's connect this one to the first one, this one to the second one. This will be our primitive name that is going to go to surface, and this will work if we bind export our surface. We will see it's the same, and if we plug this in like so, it should work eventually. So for example, if we made another position with the same position, it will disappear because now it's outside this box. But what we want to do is to make a noise. So for example, let's make a static noise. There we go. See, now we have some displacement. So I want this to be a 3D noise with Manhattan Cellular F1. Maybe this can be set to 0.1 and 0.1. So now we have horizontal lines. You see where I'm going? Let's enable lattice and let's enable warp 0.4, 0.6 and 0.1. Let's activate the fold and the amplitude will be set to 3. See, now we have a really nice deformation, but I want more. It needs more. So flow antillate flow noise. We want this one. So let's plug the position to the position, and this will be set to 0.05, 0.03 and 0.04 with an amplitude of 25. Let's see what happens. Now we're talking. This looks way better. We have this clipping issue, we need more voxels, and we can copy and paste this one here. Remember, this should all be in 3D. There we go, and there we go. And this can go to 0.5, it can go to 0.5, oh nice, and to 5. So we got this interesting shape. I like it so far. Perhaps we can lower this to 0.15 or something like that. 25 was okay. And we can hop off and move this to maybe 50 by 50. So we can fix these holes. Maybe this should go to 0.4 instead, so it's faster. There we go. Now if we convert BDB to polygons and this set to 0.05, we will have this mesh that we will easily poly reduce. So let's copy and paste this one here. There we go. This is our collision mesh for the rocks. And we can add even more. So I am going to add even more. The only thing I need to do is to merge one top of here. Okay, so what I actually did was to add a little bit more boxes with a BDB from polygons on 0.6. Look at this, this is actually very cool. I added a couple of rocks here because I thought this would look cool with this BDB from Bobs. I changed these values a little bit. You can see it here, not much to be honest. And I add outrocks call SDF, the same as here, and outrocks call poly, the same as well here. So let's shift O, and now we have our main collisions. Let's create the grid and let's make this, I don't know, 370 by 970. This will cover the whole grid. And let's select, without changing anything, these points. Select these points and let's make an edit. So let's increase with the wheel, doing like so. I don't know if you can see it. There we go, the smoothing. So we can decrease this and perhaps we could rotate this on the y-axis just a tiny bit. This should work. There we go, like so. Perhaps we can move this line on the world and lower it a little bit, like so. This should work just fine. There we go. So now let's add a null, and this will be our out main shape. Let's make a volume extrude. This will go to -30. And what we want to do is to actually grab this whole part here, right? So we're going to use the same method, but in this case, instead of 0.7, I guess, we're going to use 1. And this should be it, our rock. There we go. See, these are our rocks. It looks quite good, in fact. And if we convert this should be our polygon. We can reduce this a lot more. Yes, this is okay, and this will be our out cliff call SDF. and this will be our out clip called poly. Shift O to this. Nice. So we got our colliders, right? So what we need to do is to create the source. But before creating the source, let's create a box approximately where we are going to have our source, right? So just so we can have the numbers. So what I want to do is to have something around this. This is okay. I need to move this a little bit. This is going to be our bound box, remember. So this is going to be the box, right? We will have this just to have the numbers. So I want to BDB combine some guys here. I will use this one. I will also load this one. Remember, all the SDFs can be combined. I will use this one, right? So if we do the following, we will have this BDB and we can combine with an union. Now we have the boat, see? And if we make another one, we will have the rocks and we have everything stick together. Why we want to do this? Because if we are going to make an ocean surface of these categories, we want to delete everything that's outside, everything that's inside these shapes. So let's create an ocean surface, ocean source. So to start with, let's go with a value of 1 and let's grab our box and let's control this guy here, paste relative. In fact, in this case, we're just going to paste values. There we go. Paste values. See, now we have everything here. If we plug this into the second one with collision geometry, we should have once we add these values and surface evaluation set to flat. See, now we have this grid, but we need to make it higher. So do you see we are standing on the ground? So if we set 30 meters, now this is on top and it's avoiding the geometry. We're going to set a split and the split is going to be set to surface. So on the one side, in this case, we place a null. We'll have the initial polygons, the initial particles. So this will be out initial. And on the other hand, we'll have the surface, out surface. It doesn't look like there is something, but this box says us there is, plus we can see the surface here in voxels. So this is going to be our source, right? So the collisions, this is going to be the source, and now we should actually create our flip simulation. So what we can do is to use this box as the B box, right? This is going to be our controller. So let's in fact copy and paste relative. I know I said before we shouldn't, but now that I think about it, this is a better option. So let's copy and let's paste it here because we're going to use it now inside our Dop Network, like so, right? So this is our network. We need a flip solver and we need our flip object. Okay, so what we want to do is to go to the particle motions and volume motions in the box size. So let's go here and let's copy the size, paste relative, and we should go back and copy the center and basically plug it in here. So on the volume motion, and volume limits, we will want to use a waterline. This will be a tiny bit less than what we got inside here, right? Look, a tiny bit less than our ocean surface waterline. I think this viewer is back. There we go. We should be seeing with the visualize our waterline. We should enable the particle narrowband. This will make, if there is a wave, it will go outside and it won't collide with the borders. We're going to change this to swirly, and we're going to add vorticity and droplets, so to 1 to, let's say, 7 or 8. This will detect this as droplets if it has like nearby particles. Let's say one particle has 8 neighbors, it will detect it as a droplet. That range will become a droplet. And on the flip object, we're going to use a particle field, and on the flip object we're going to delay, and on the flip object we're going to use a narrowband. We need the subpath, so let's copy in. This will be our initial, and the surface volume will be our out surface right here. Needs to load. This takes a while, and there we go. So one more thing is that I don't want these spheres as guys, I want my particles as particles. There we go. We also want to have some gravity, and let's see what happens once we add gravity. But we want to have the particle separation here set to at least 1. Let's copy this, so our source it's equal to our particle separation. The same we're going to do with the grid scale. It's always nice to have everything linked together. So let's see what happens if I press play. So this will happen. It detects the collisions and it adds it together. So in fact, I don't think that we really need to have this bottom part colliding with this source, right? Let's see these rocks at the bottom, cliff called poly. See, perhaps we can just avoid this because the waves are not going to go that far below. This should be fine for the most part. So let's load this again. Now we have our simulations here. Perfect, 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 right? It's falling down because we don't have closed boundaries. We should in fact close our boundaries. So below this it will be closed, and on top of our waterline it will go away. That's why we need to have our waterline a little bit lower inside our flip solver. So I guess this is working fine. We can even lower this particle separation so it's even faster. There we go. Nice. So it's working. We just need to add the collisions. So this is the fun part, at least for me. And let's make a merge on top. Let's do another merge because we're going to use multiple collisions. And let's add a static object. The static object will be using 2 things: our SDFs here, our polys, and our SDFs inside our volume section. This will be a volume sample, and we'll use the proxy as our call SDF. So, you know, the way we name the things are very handy, because now what we can do, this is the cliff, and I know this can be the ship, for example, and what we only want to do is to go here and change the name to ship here too, ship. And we should disable this geometry because what we want to do is to view it here in the guide visualization collisions. First frame we won't see anything, second frame we will start seeing the interactions. So we need the rocks. This will be, I believe I call it rocks, if I'm not mistaken. Rocks, yes, there we go. Rocks, and I think there's nothing else. This should be fine. Yes, these are the rocks. See how everything is working. It's not falling, it's just there. Nice. So what we want to do now is the waves. So for the waves we want to Ctrl Shift Alt and drag this to have the same grid as our cliff. See? and we're going to create the waves out of this guy. So we want to make a poly extrude, right? This will go with the local control and extrusion set to global, and we will move this guy above. And let's output back so we can have a back face. There we go. So with this, what we want to do is to perhaps have more rows. So let's make them, let's have more rows, and let's make them a tiny bit more square. See, this is bugged again. There we go. See, now we have some kind of squares. I don't know why this is so bugged. It's my good version. There we go. So what we want to do is to use a rest position, and then to use an ocean evaluate, and then an ocean spectrum. We can see this is moving somewhere, but what we want to do is to increase the grid size to perhaps 300, if I'm not mistaken, or perhaps I'm missing. So we want to move this guy to 1000, this to 9, this to 600 meters. Kind of, it doesn't need to be so precise. Perhaps the gravity is set to 7, so the waves are bigger. On wind, I'm going to have a lot of wind with a lot of direction bias, and the chop is okay. And on amplitude, I want to have even more amplitude. I want this to be like really harsh, and the mean wave length set to 0.3. And on mask, we can add a little bit of noise, and we should have something like this as the waves, right? They are moving forwards to the exposition. If you want even more, we can add like a multiplication, set this to 2 and this to 2, right? Now we have more resolution. These are going to be our waves, or at least how they're going to be advected. So now what we want to do is to create a wrangle. In this case, we know we have a rest, and we should in fact create a gradient going to the x position, 0 to 1. This will be nice. So let's make a float of the CD that will be equal to the rel bbox of what of our p at x. See, now we have a gradient. This is really nice, and we can run this gradient. For example, if we make a fit, and if we make a ch ramp of a gradient, and let's load this in like so. See, now we can move this around, and I want our b at p to be equal to the lerp, to the linear interpolation of our b at p, our b at rest, and this will be our amount cd. See, this works flawlessly. So let's invert these guys together. This should work. Something like this is okay. And moving it like so. We need to see the ship, so we know where the waves are going. Okay, so this should be the opposite. My bad. There we go. And something like this should work just fine. And let's do a monolithic ramp. So I want to have all the noise just here. We don't want to have noise, or not that much noise here. Maybe a little bit, not that much. This should be fine. So let's trail this guy. Oh, in fact, I'm going to be calling this to mask, right? So now we're going to set this to mask. There we go. This is fine. Okay, so let's trail this. We need the velocity. Remember to use the central difference because it's way better. We can do an ISO offset here. The ISO offset is going to be set to 10. So we can in fact use scatter node here. This scatter node will be set to reduce iteration 0 and more points, because what we want to do is to create a point deform. This point deform will be driven by this point here. So this offset should be set here, and the time shift should be go here on the first frame, with the first frame, and we also need to have this guy here. See, now the points are moving, really nice. Perhaps we need way more radius, because the size is really big. Now it's moving a lot better. See, this is very cool, and we want to use a trail node here. So we see the trail. If we increase, remember this is a really big scale, let's increase it by a lot. There we go. So now the nodes are moving really nice. From polygons, where we're not going to have a surface, we're going to have our point B set to displacement acceleration, and this to B. We should have this to 4, and we should be able to see something. So now we should do a BDB from particles, and we are going to use this as 4. We're not going to have surface, and we're going to have our B set to displacement and this to val. The point radius scale matters, so perhaps a value of, I don't know, 40. There we go. And we have the velocity. Perhaps 20 is better. And we're going to use a file shape labs. Remember, if you want this node, you need to go to Windows and sidefx labs. I'm going to save it to chain. This will be called out B, or just B. This is the first version, and load from disk. We want the whole range. In fact, I'm going to change the range to 48 in this case. There we go. Let's save this, and let's look at it, and let's save to disk. Okay, so we have our simulation here. Well, our velocities, and they are fine. If you want to see this, we can use a volume rail, and we can make a grid. This a grid, and this will be our points. This will be our velocities, and this should go here, and this should go like so. We could rotate this 90 degrees and have a ton more points. So watch this, we just need to choose our velocity and increase our trail length here to 20. So these are our velocities. I guess they're cool. So now that we have this, we make a node, and this will be called out B. We're going to hop into the Dop network, and we're going to use a pop advect by volumes. We're going to load in the out B, and this will be treated as a force, and this as not as wind. So something as this should work. Remember, guys, this volume should be intersecting these waves just a tiny bit. It doesn't need to be this big. In this case, I exceeded a lot with the sides, I believe. Perhaps 5 and 7 and 8, and this maybe to 3, to 2, 4, to 15, to 1. There we go. We should reduce this a lot more, and then we need to move around with these values until we got a nice mixture of things. There we go. This is nice. Set this to 2, and perhaps this a tiny bit bigger. So this is fine. We have this amount of volumes. It's fast to calculate, It's not that hard or demanding. And if we take a look, we have these velocities which are better than before. Before this, they were like this, now they are like this. So this is fine. So let's save this again. Okay, so we have this. We can check with our initial particles if they are working. So this is nice. We can imagine that they are going to be dragged by this volume, right? So as you can see, it will work just fine. I might, and this is not a problem, guys, nothing will happen if you transform this a little bit. Remember, these are not meant to be perfect effects. This should be fine. There we go. Okay, so let's hop into our simulation now and let's see what happens. So at first glance we can see something is going on. In fact, let's create a flipbook so we can see better. So this is nice. I would like to see a little bit more action. So perhaps what I want to do is to reduce the particle separation. I make another flipbook and let's see. This was set to 2 and this will be set to 1.3. So let's check again with another flipbook. Okay, so now this looks way better. As you can see, we can identify a couple of waves going to the right side, and I think I'm going to keep myself with this one. It looks quite nice for being such a low resolution. So let's close this. So I am going to teach you another variation with where we are not going to use this one. This is only for you to keep in mind that you can use both of them. So the other variation is to go to our polygons, go to our BDB from polygons and set this to 4 and add this attribute, the velocity. Remember to copy this guy and let's add the velocity and the displacement and this set to B. We're going to make a switch and we're going to compare right here. We can use both of them, right guys? So in this case we're going to bypass this node and we'll see if you go here to our trail that this is a little bit more uniform. And you can see that if you go to the first one, this is a little bit more uniform and more controllable, which is better, at least for me. We can obviously use this one, this is more natural, but this one is more controllable. So feel free to use whatever you feel you see fit, right? Okay, so I'm going to stick with this one. And we're going to save this into another section. This will be the velocity. I'm going to put the velocity here, right? So as you can see before, we had a problem. I don't know if you noticed. So the problem was that if we have waves, the waves shouldn't move here, right? Because I mean, the waves are crashing here. So let's go on, we are going to make a little trick to fix this issue. So let's merge two guys together. First of all, our rocks, and let's grab another one, which will be our ship. So we have this one, these two guys. And what we want to do is to grab a group node where we are going to be selecting the normals. The normals are going to be facing on the x negative position. So there we go, like this. And we move this slider, we can select all these polygons, which is very nice. We're going to blast this with a blast node, selecting obviously our blast group set to invert, and we're going to poly extrude this guy all the way to our right side, like so. This should be set to output back, and this will be reversed. And we're going to make a BDV from polygons from this. We don't need to be so secure about this. A box of size of 4 will be fine. So before creating this mess, we need to somehow mix these guys together. So what we can do before this placing is to group these guys together right here, even before our poly extrude. So let's do the following, and we're going to group this set to the mask, and this is going to be bounding box set by volume on points. See, now we have our shadow. We can do whatever you want here in the poly extrude, for example scaling it on the Z position, but we don't need this. Perhaps a little bit smaller would be fine, I guess. See how this changes. I like this a lot. So we can actually create our mask now. Let's do a f at cd equals to mask, and our f at mask will be equal to 1 or to 0 in this case. Everywhere we have a mask, right? This is only to visualize it. So we can blur this guy with an blur node. Actually it's blur, and let's see what happens when we plug in the mask. We're going to iterate a lot, step size will be bigger, and we can pre-visualize this with the CD. This is how it's going to look, and we can take this to have smooth edges. This is a really nice function. So now that we have this, we can in fact do the following. And on our wrangle, if you recall, we have the f at cd equals to f at mask, but we don't see this mask here, but we had that mask. In fact, we could do f at gradient or float gradient, that will be equal to this guy here. So if we put gradient, it should be the same, right? But we already have a mask value. For example, if we set this to nothing, we will see, in this case we should use a 1 here, and if we go here, let's see, now we have the mask, we can see it, see? But if we set this, that is going to be multiplied by our gradient on a fit 0, 1, where our gradients will be inverted. We can see this guy working, and let's see how it moves. So we have a lot of noise here and not so much here. We can move this a little bit, and we can do a gradient 2, and then this should be set to f at mask multiplied by this inverse gradient, but we're going to add a gradient 2. So now we can select the initial part, so it's going to be something like that. So we are going to have the control of the initial part, we're going to have some waves, and we're going to have this mask. What we also want to do is, just so we can have a little bit more space, is to decrease this guy here and increase this grid just a tiny bit here. There we go. So we can have a little bit more space in our simulation. This should be fine. There we go. So on the bottom channel we're going to see this guy is moving a lot and this guy is not moving so much. So one thing that I noticed is that this is at the bottom level and we want to be more precise. So let's grab our ship and let's grab our particles here, out initial. So we want this grid to be set somewhere on top. So we're going to delete this channel and move it a tiny bit to the top. So our masking will be precise. So as you can see, if we move this to the bottom, it will change as we move. This is okay, right? So now we have more precise mask and we can actually see this without the transform node and everything should be set. So let's just see our initial. Yeah, this should be fine. In fact, we're going to move this a little bit downwards like so. There we go. Okay, so let's hop into our simulation and let's make a flipbook. So we have this simulation working. I believe this is very nice, easy, fast to simulate, only a couple of minutes. And we have these waves here and we don't have any waves here, just as we wanted. In fact, I think I have too much of a space here, but it doesn't matter. So one thing that I would like to do is to move this here. It won't change anything at all, but I do want to have a pop drag here, and this should be set to 0.050. This will set a little bit of drag if there is any particle messing around. We need to Dop import our fields. They will go here and we're going to open the flip object. This is going to be using the filter flip fluid and we're going to fluid compress this guy. But this guy is going to use this particle separation of 1. So we have this. If we unpack our points, we can see we have the simulation. Okay, so what we want to do at the moment, ignore this, is to save everything. File, cache labs, and this is going to be called fluid compress. And it's going to go to cache, and load from this will be used later on. So this will have a null which is out fluid compress, and we are going to blast everything that is not our velocity and our surface. This will be out. This will be our main fields, and it will be obviously having its own null being called out main fields. Okay, so now that we have this, we can add our white water source. In this case, let's go instantly to our voxel size and let's use a 0.5. We don't want acceleration, we do not want curvature, we only want it to go to from 1 to 3. Let's see how it looks. Okay, it looks promising. We might be needing to have a little bit more particles eventually. So let's go to frame 120 and let's see how it looks. So as you can see, basically our whole simulation now has a little bit of white source added into. We only have 1.3 million voxels, so we can even go even further to, let's say, something like this. to 5 million. It doesn't change the overall look, so let's stay as we are. Okay, and this will be obviously saved into somewhere which will be called white water source, and I'm going to set all of these to lowercase. So let's create a null saying out white water source. One more thing that we need to make is our actual mesh. So right after this we are going to split. What are we going to split? Our surface, and we're going to invert the selection. We're going to use a particle fluid surface set to if this guy lets me. Don't forget to just copy the particle separation and paste it here. So now we should have something like this: particle compress fluid. No, the particles, only the particles. There we go. And we want to split our droplets, which in this case we do not have that many, but we are going to use add droplet. My add droplet is less than 0.1. So let's see what happens if we go to points. Droplet. See, we barely have any droplet at all. This will fix a couple of issues where we don't have that amount of resolution in our mesh. Right now it's removing a lot because we don't have, this is not such a high-res simulation. So we can go even further, perhaps. Let's go here until we have a number we are pleased with. And we should merge back our fluid surface with our particles. Why, you would say? Because of the following. Look at this. If we go this, if we go here and go to surface polygon soup, we will have this bounding box. If we remove this, we won't have, and we need this to be here in order to remove it. We also need to have a couple of things. For example, our collisions. We need this SDF, and we're going to plug it into the collision shape because we want to subtract the contact points. So we're going to go here into filtering and into regions, and then subtract collision geometry. See, now we have these Boolean kind of shapes. We're going to set a normal to points, and we're going to use the following. And then surfacing, this is okay, but we want to have some adaptivity, maybe set to 0.5. So this is a lot, so perhaps 2.5 will be better. Okay, so now that we have this, we can use the following code: geometry density. Okay, so this code, what it makes is detects the amount of points nearby. So we're going to increase the radius, and as you can see, it's like a kind of curvature but based on density. Why are we going to make this? Because as you can see here, this is going to be CD, but we're going to translate it to mask. We have the same values but set to mask, and here we are going to use b at p will be less and equal that b at n multiplied by CHF, our multiplication value, and it will be also multiplied by our mask. So as you can see, we are making these parts, we're making these parts go a little bit inside. This will be better seen here, for example. Instead of being so flat, so chubby, I believe we can introduce and like, instead of being so fat, we can make them a little bit thinner. In fact, we can blur these normals a little bit, and it will change the behavior. We can obviously compute the normals again after the fact. This will look a little bit better. See, this is fine. So let's recompute our normals so we stay consistent. See, this is without computing, this is with, and this was before. We are blurring and we are offsetting inwards. Let's go back into the wire shaded. Finally, what we want to do is to boolean this guy. We're going to use this box, at least a copy, as a starting point, and we're going to have this shape right here, and we want this to be an intersection of a surface. Now, this should be solid and this should be the surface, if I'm not mistaken. There we go. This should be set to no polygons, and don't forget to actually convert this guy into usable points. There we go. So let's move this guy here, so we can have our shape working perfectly. So this is only for rendering, and this boolean should work just fine. And we're going to save this guy as the mesh. Null set to out mesh. I'm going to shift O, and this will be the flip part of this achievement, the flip part of our stage, and this is going to be the flip cache section. Okay, so now the only things that we need to do is to make a Dop network where we are going to set up our whitewater simulation. So let's do a whitewater solver, and let's plug in our whitewater object as usual, and let's add a merge. And remember our collisions on the other simulation, we are going to copy and paste them because we do not need to set it up again. So let's go here, copy, paste, copy, paste. There we go. We have our collision geometries, and what we are going to do is to actually have a pop advect by volumes set here on the post solve. We're going to set it up later, so we're going to leave it like this. So what do we need to set up now? We need to set up the whitewater object and the whitewater solver. So for the whitewater solver, we need a couple of things. The aging, I want this to be really fast and the spray to be really low, and we want the volume source is based on our flip simulations, so we want to have the main fields, and the emission source, of course, is going to be the out whitewater source. We might not want so much velocity, so we can go to 0.5, and on foam we do not want to have the repellent right here. We do not want to have these repellents. This means that we're not going to have like a fluffy shape, and we should always add this state attribute in case we want to do something. Hence we have bubbles or we have foam or whatever. This will help a lot. And we only need to set up one more thing, which is the pop advect by volumes. We are not going to use the previous one, we're going to make a new one. What do we want? We want to have some kind of wind here, so this is going to be pretty easy to set up. So what we want to do is to create a volume, but this volume is going to be based on a box, and the box is going to be based on our previous simulation, where we need to go to volume motion. Let's copy the box size, Ctrl+1 to set a shortcut, Ctrl+2 to set another one, and we can paste it here on the box on the size, paste relative reference. Then we can box center copy parameter, and we can go to the box right here and paste relative reference. So now we have this kind of shape, and we want to have an initial value of 1, and we want to have a vector which is going to be called velocity. This is our box, this is our volume. It should be working just fine, and the sampling will be set to 100 so we can fill this up. So now we have 92,000 voxels, which is enough for what we want. We want to add some volume velocity, and the volume velocity will be having this. We'll have a curl noise, but the curl noise is going to be also added on top of a velocity, and I want this velocity to go on the negative axis, so minus 6.5, 450 is going to be the size, so the size is going to be really large, and the pulse length, so it's not that fast, it's going to be set to 50. So we cannot see anything. How do we visualize this? Easy. Let's make a grid. Let's make a match size. Let's plug this here, plug this also here, and we will set scale to fit. This won't be a uniform scale, and we're going to rotate this so it's vertical. So let's add a little bit more rows, more columns, and let's do a volume trial so we can visualize this. Let's go to the points, let's go to the volume, and let's use the velocity here, all the trends of the velocity. The trail length is going to be 10, and we can see that over time this is going to move. This works just fine. Remember, we're working on a really big scale, so this is more than enough. We can obviously add some more distortion with more turbulence. For example, this can work a little bit better, I guess. There we go. So null out white water velocity, or B, in fact. Let's move this around. Let's shift O. Let's hop in and let's plug these guys together. And this should be just fine. If we simulate, we should have something working already. But before testing this out, we are going to attribute delete. There we go, attribute delete. And we're going to load a couple of frames to start with. One frame should be enough to have. And remember, we only want to have our white water objects right here. Let's copy and let's paste the same name. Remember, www the same as www. So we should be having only what we want. So I'm going to simulate a couple of frames. One more thing, let's not forget, obviously, about copying these guys in the limits of the white water solver. There we go. Now we're going to start having the correct parameters, and there we go. Now this should take a while to simulate again, but it's going to show all of what we need. Remember that we can use what we had before and only change a little bit the colors, and we can be able to visualize. We won't have any vorticity, but we will have velocity. So we can shade this up a little bit with the colors that we want. So we can distinguish between one and another simulation. In fact, if we merge these two guys together, we can have a really nice look. See? This is the normal simulation and this is the white water. So let's go to frame 120 and let's see what happens. Okay guys, so I took a look into my original file, and the only difference between these guys are, for example, the resolution, which is set to 0.25 on this one, and on this Dop network we didn't change anything pretty much. This is all set to the what we had on the tutorial. But as you can see, with this, we already have really nice results on frame 240. Remember, this is the same you have on the tutorial, and we are starting to get a really nice result. I would like to have maybe more particles here, but we can post-process this, or we can just spend more time on simulation. Remember, this was made on a Threadripper, on a 3970X, and it must took around, combining both simulations, around 6 to 7 hours to simulate. We have 13 million points on the wet water, and we have around also 13 million points here. So if we combine these two, we have 27 million particles, and we can obviously move these values around, and it should change as soon as I do something with it. Right here, see, they can move, and we can control how it looks, as you can see. And if we merge even the colliders, we should have something like this. If we go right here on the, we combine it on the cliff, and we have the cliff. We can also have this one, the ship. This is the low res. And if we have these rocks, the setup, remember, is almost the same, and it looks quite nice from a certain distance. This could work. Hello guys, thanks for watching the video. If you want to comment something, please leave a comment down below. If you want to join my Discord channel to learn even faster on a community full of FX artists, then hop in. See ya!